Section 13.6 is on probabilities of mutually exclusive events. Mutually exclusive events cannot happen at the same time. In other words, they have no events in common. Let's take a look at a couple examples here. Determine whether the events are mutually exclusive or are not mutually exclusive, and then explain. So the first situation is drawing an ace or a 9 from a deck of cards. This situation is going to be mutually exclusive. And that's because a card cannot be both an ace and a 9 at the same time. Okay? So if the two events cannot happen at the same time, they are mutually exclusive. So a card cannot be both an ace and a 9 at the same time. Here's a second example. Drawing from a standard deck of cards, a king or a club. So this is a case that they are not mutually exclusive because a card can be both a king and a club at the same time. Because there is a king of clubs in a standard deck of cards. So let's see, a card can be both a king and a club. So this is a case where the two events can happen at the same time. So the probability of mutually exclusive events is defined as follows. If the two events are mutually exclusive, then the probability that one event or the other occurs is the sum of the probabilities of the two events. So in the previous section, we multiplied the two probabilities, and if you'll notice, that's when we used the word and. What was the probability of this happening and that happening? So two events are happening, you're going to multiply. In this section, we're looking at the probability of one event happening, and the two events, the two probabilities are not cannot be happening at the same time. In this case, basically, if you're going to see the word or, you're going to add them together. Here's an example. A jar contains 30 quarters, 25 dimes, 40 nickels, and 15 pennies. What is the probability that a coin drawn at random is a quarter or a penny? Okay? Notice that we're only drawing one coin. So what's the probability that it's a quarter or that the coin is a penny? Well, there are a total of 110 coins in the jar. 30 of them are quarters, and 15 of them are pennies. And because a coin cannot be both a quarter and a penny at the same time, these are mutually exclusive of each other. So here we just add the probabilities. Whoops, that should be 110. 45 over 110, and then always reduce your fractions. 9 out of 22. Here's the definition of the probability of non-mutually exclusive events. If two events are not mutually exclusive, that is, that both events can happen at the same time, then the probability that one event or the other occurs is the sum of the individual probabilities of the two events minus the probability of both events occurring. So, if something can be both A and B at the same time, I'll add the probability of A to the probability of B, and then subtract the probability of it being both at the same time. This will make a little more sense when we take a look at an example here. What's the probability that drawing from a standard deck of cards, a king or a spade? Okay, so I need the probability of a king or a spade. Notice again, in this case, I'm drawing just one card. I'm using the word or, so I will be adding. So this is going to be the probability of a king plus the probability of a spade. And because a card can be both a king and a spade at the same time, that is the king of spades, I need to count subtract the probability of the king of spades. And here's kind of the idea why. As I count my kings, okay, that's going to give me 4 out of 52. And then when I count my total spades, that's going to give me 13 out of 52. But in this category right here in my kings, I've counted the king of spades. Here in my category with the spades, I've also counted the king of spades. And I can't really count them twice. So I need to subtract the probability of it being both at the same time. So that's going to give me 16 out of 52, which reduces to 4 out of 13. So if the two things can happen at the same time, you need to subtract the probability of it being both at the same time. The complement of an event consists of all of the outcomes that are not outcomes of the given event. So to figure out the probability of that, we do the probability of an event not occurring is 1 minus the probability of the event occurring. And that seems pretty obvious. So if the probability of something happening is, let's say 25%, then the probability that it's not occurring is going to be 100% minus 25% or 75%. And here's a very basic example. If the chance of rain is 70%, what is the probability that it will not rain? Okay, so basically that's going to be 1 minus 0.7, which is 70%, which is 0.3, which is 30%. Or you could do 100% minus 70% for 30%. So the probability of something not happening is going to be 1 minus the probability of it happening. So this section was all about mutually exclusive events. And the main idea here was we were doing one situation, we're drawing one card or drawing one coin from a jar. If the two events are exclusive of each other, something cannot be the two things at the same time, then we just add those probabilities, as we did with the coins here. The coin could not be a quarter and a penny at the same time. If they're not mutually exclusive, you're going to have to subtract the probability of both of those events occurring. So for example, with our king and our spades, since a card can be both a king and a spade at the same time, we had to subtract that probability of it being the king of spades.